All right, welcome to The Explainer. Today, we're diving into a story that a lot of people just sort of write off as another space travel milestone. But honestly, it's so much more than that. The rise of SpaceX is literally a masterclass in weaponizing absolute, crushing failure to drive unprecedented innovation. We're going to unpack exactly how a scrappy little company, one that nearly died before it ever even reached orbit, somehow managed to completely upend a deeply entrenched, monopolistic industry. I want you to put yourself in this seriously high-stakes situation for a second. Imagine pouring millions of dollars and literally years of your team's life into this insanely complex orbital engineering, only to stand there and watch it vaporize in a massive fireball, right? And now imagine it happening again. And then again. I mean, most people would just cut their losses and walk away, right? But that agonizing reality of watching your life's work go up in smoke repeatedly is exactly where our story begins today. It's totally defined by this shocking, almost stubborn refusal to quit. So you gotta ask, what actually drove this refusal to just give up? It all comes back to one massive question. Can humanity become multiplanetary? Think back to the early 2000s. Elon Musk was fresh off this huge PayPal buyout. He was in a position where he could have, just bought a private island, a fleet of jets, and enjoyed his newly minted fortune. But instead, he channeled all that wealth into a massive, civilization-altering ambition. He fundamentally believed humanity had to expand beyond Earth, first to the moon and eventually to Mars. But yeah, there was one enormous roadblock standing in the way. At the time, the entire aerospace establishment operated on this one painfully expensive rule. Rockets are expendable. Just think about how insane that business model actually is. It is literally the equivalent of building a brand new 747 for a single commercial flight, only to intentionally crash the thing into the ocean the second it lands. The costs were just staggering. So SpaceX's 2002 vision aimed to completely shatter that paradigm. To make humans multiplanetary, the real challenge wasn't just getting to space, it was building rockets that could eventually be reused, making spaceflight drastically cheaper. To even begin tackling that seemingly impossible goal, they started with the Falcon 1. Now sure, it was completely dwarfed by the towering legacy rockets from established space agencies, but this was an immensely complex machine powered by their totally new in-house Merlin engine design. Behind this vehicle were years of intense engineering, some serious, scrappy duct tape problem solving out on a tiny Pacific island, and of course, massive financial risk. Despite being relatively small, this little rocket carried the absolute weight of the entire company's survival right on its shoulders. But look, the reality of spaceflight is brutal, and the timeline of their early attempts captures that chaos perfectly. March 24th, 2006. Launch 1 fails shortly after liftoff because a fuel leak ignites a fire. Total loss. A year later, March 2007, Launch 2. The rocket actually rises, but propellant slosh causes it to fail before reaching orbit. Then, August 3rd, 2008. Launch 3. The rocket climbs, everything is looking completely flawless, but a timing error during stage separation causes the stages to actually collide. Just another total, devastating failure. Which brings us to September 28th, 2008. Three consecutive, completely catastrophic failures. And you have to realize, for SpaceX, these weren't just little technical hiccups. These were financial death blows. Musk had poured his own personal fortune into this dream, and by 2008, the company was just bleeding dry. Let's be real, in literally any other industry, 3 strikes means you are out. Which brings us to a pretty stark, terrifying reality. 1. Musk had exactly 1 rocket left. That's it. The money was gone, there was absolutely no backup plan. If this 4th Falcon 1 rocket failed, SpaceX and that whole multiplanetary dream died right there with it. So, September 28, 2008, the countdown begins for that final do-or-die attempt. 10, 9, 8, ignition. The Falcon 1 climbs up through the clouds. First stage works perfectly. Stage separation is beautifully clean. The second stage ignites, pushing its way through the upper atmosphere. And finally, success. Against all odds, after 3 just soul-crushing failures, this scrappy little startup achieved what the aerospace giants honestly thought was impossible. They actually reached orbit. Okay, but reaching orbit, that was really just the starting line. To truly revolutionize the industry, they knew they had to scale up and fast. So they engineered the Falcon 9, clustering 9 Merlin engines on the first stage to massively increase payload capacity. But their real ambition went so far beyond just launching a bigger vehicle. The ultimate goal was to actually solve that 747 problem we talked about earlier. Whatever you do, do not throw this massive multi-million-dollar machine away. Launch, land, reuse? I mean, it sounds so simple on paper, right? But making a rocket land vertically is a staggering physics problem. It is an entirely different beast from launching it. You are basically taking a building-sized cylinder, falling from the edge of space at supersonic speeds, and trying to gently set it down on a tiny target. Come in too fast, you crash. Too slow, you lose control. If the trajectory angle is off by even a fraction of a degree, the whole shebang is over. So how did they solve it? Through brutal iteration. Fail, learn, improve, repeat. Over the next few years, SpaceX experienced multiple, what they famously call rapid unscheduled disassemblies. Basically, rockets completely missing the autonomous drone ships, tipping over right at touchdown, or just coming in way too hot and erupting into massive fireballs. But here's the thing. Every single disaster generated vital telemetry data. The engineers meticulously used all that debris and data to tweak the grid fins, adjust the radar, and perfectly refine those engine burns. And all that painful, explosive iteration finally culminated in this absolutely incredible moment during a very tense night launch. The Falcon 9 first stage separated in space. The booster flipped itself around. The engines fired in a perfectly calculated re-entry burn. The guidance systems rapidly adjusted the trajectory as this concrete landing pad slowly appeared below in the dark. The landing legs deploy, and then it happens. A rocket landed vertically back on Earth. They actually demonstrated that a rocket could launch a payload to space and come safely right back home.
Now, why does this matter so much? Because reusability equals drastically lower cost potential. This was not just some highly impressive PR stunt. By reusing major flight components over and over, the fundamental economics of spaceflight flipped overnight. With this one single technological leap, SpaceX went from a struggling, near-bankrupt startup into an untouchable, industry-changing powerhouse. It was a total game-changer.
But of course, they weren't finished. This iterative philosophy birthed their most ambitious project yet, Starship. We're talking about an enormous, fully reusable vehicle designed with the ultimate goal of carrying massive amounts of people and heavy cargo farther than we've ever gone before. It's basically the ultimate physical manifestation of that multiplanetary dream, specifically aimed at finally reaching Mars. But as you can guess, building a vehicle of this unprecedented, towering scale requires unprecedented and often highly explosive, repeated testing. To stomach that, it requires a massive psychological shift. Failure does not equal the end. Just like in the early days of Falcon 1 and those drone ship landings, several Starship test flights have ended in spectacular mid-air explosions. And sure, to a casual observer watching on the news, it looks like a total unmitigated disaster. But to a team of thousands of engineers, a destroyed rocket is actually a vital, data-gathering laboratory in the sky. Every single sensor records gigabytes of data. Every structural failure reveals exactly what needs to be reinforced for the very next flight. Keep building, keep learning, keep going. Look, the story of SpaceX isn't just about rocket engines, and it's certainly not just about one guy. It's about what happens when thousands of brilliant people flat out refuse to let failure be the final word. So, the real question I want to leave you with is this. When you face your own catastrophic, explosive setback in life or business, will you pack it in and go home? Or will you use the data to build your next attempt? Thanks for joining me on this explainer. I'll catch you in the next one.